Hi, fellow geochemists and geochemistry enthusiasts. Welcome to GeoChemISTea, the only podcast for people who love geochemistry with a side of tea. Our mission is to inspire future geochemists and to introduce our listeners to niche geochemistry topics. I'm your host, Sam Scher, and this month we're talking with Simon Griffiths about geochemical exploration in low-sulfidation epithermal deposits. Simon Griffiths is the principal consultant at Third Planet Exploration Services. Simon, welcome back to GeoChemISTea.
Hi, Sam. Great to be back.
You sound so excited.
I am. Always excited to talk to you, Sam.
Woo! So Simon was our first guest and talking about geochemical exploration in Carlin Gold. And since then, he's talked to us about geochem exploration in high sulfidation epithermal and greenstone gold. So I would argue the world knows you at this point, Simon. Since our last installment, I was wondering if you could share with our audience anything new that you've been up to, insights perhaps into what it's like being a consulting geochemist.
Yeah, last year, we've just been carrying on working, as a mostly geochem consultant, although people started bringing me in on exploration, I guess pipeline management, we used to call it, but basically strategies and how to rank and prioritize certain portfolio of projects and move them through the exploration stages. Saudi Arabia has been a place where there's been quite a lot of activity, and I've been working with 2 or 3 groups there on some projects, some regional stuff, but also some project scale things as well. Yeah, a couple of projects in Africa, a few in South America now as well. That's been pretty good.
Diversifying, how
Also,
interesting.
also hired another person. So now I've got Aidan, who's been with me for a couple of years, and Harry Brooks just joined us earlier this year as well. Oh, and we're pretty stoked because we had an oral presentation and a poster accepted for the SCG conference coming up in late September as well. Been really busy.
Yeah, things are looking up. I love that. Very cool. Otherwise, I guess now that you've been in the business for what, about 5, 6 years now, is there anything that you could share with people that are thinking about maybe this is the path for me?
Not really. I'm in a sort of a bit of the situation I'm in is that because I worked all over the world with large companies, I've got a pretty good big network with people who I've worked with over the years who are now either still in those companies or basically running exploration groups for mid-tier companies and some junior companies. So it was, I say, I'm in a situation where essentially I've already got the network, and basically just people just call me, or I get WhatsApp messages, can you come and help us out on this or that? So I think going out and being a consultant, you've got to generate this network somehow. I wasn't thinking of this, obviously, over my career. I was just doing my thing at the time. But it turns out that after doing it for 20 odd years and then starting about 25 years and then going out into consulting, it was to say you got the ready-made sort of contact list. That's a big help.
Yeah, I think you make a good point. I think it's a combination of not one for the faint of heart, but then also some kind of network already existing is going to be really important before you make the plunge. I have a vastly different network than yours, but it wasn't like immediately successful. You have to be in it for a little bit before people are like, oh, she's available, she can help, or in your case, he can help.
Yeah. Yeah, as I was considering doing this, I spoke to another geochemist who was consulting at the time, and he said it'll take your network about 6 months or so to realize or believe that you're not going to actually just go back and get another full-time job. And then they'll start calling you. And pretty much that's what happened. That was good advice. And so, yeah, it's not just us, right? I've heard it from other people as well. It takes a bit of time to get off the ground, but once people get the message that you're out there and available, then yeah, it starts to kick off.
Very cool. Thanks for that little intro there. As you've been so kind with us before, I think right now it's tea time. So, Kettle's hot. What'd you bring for us?
Yeah, today we're going to talk about validation epithermal deposits, and actually we're going to talk about a paper on the Porgera deposit in Papua New Guinea, which is a place where I worked a fair amount, lots of visits there as the geochemist to help the team. But one of the things I had to do as well, or another part of my role in Barrick as the chief geochemist, was to assist with lab audits, because Barrick had 27 mine labs when I joined in 2007. And when I realized that, I thought, hang on, Barrick's got more labs than some of the lab companies, right? But there was a constant routine or constant schedule of auditing the labs, and there was one person in Toronto responsible for it. So at the end of the day, I was helping this guy. So we said, if you go to any mines, big important ones that have a lab that needs auditing, can you help me out? So I go to one of my visits to Porgera. I go and audit the mine lab. And first of all, it was a whole other sort of set of admin and everything just to get into the lab. And the other thing is there was no photography allowed on the Porgera mine site, so including the lab. So I had to get a special letter from the mine manager to allow me to take pictures as part of the audit. And anyway, so I got there and the lab manager was already a bit put out that he had to take this exploration guy around his lab, and that I was allowed to take photos. So it was a little bit of an atmosphere, even to begin with. In fact, he'd been running the lab since the beginning of time, basically, and Porgera used to be a Placidome mine. And don't forget, this is in 2000, this is probably 2009 or 10 by then. So the mine had been going for about 20 years. One of the first questions he asked me was, what's it like working for Barrick? You work for Barrick? He's like, no, he was at Porgera. It's a whole different world. And he was one of the old Placidome guys, and I don't think he had changed his letterhead quite yet. Anyhow, he showed me around the mine and at the lab, and I'd been asking about whether we could use the mine lab for any of our exploration work, at least the near mine exploration. But we needed to do multi-element analyses, and the mine lab only ran gold, silver, and maybe 2 or 3 other elements. The lab, he opens this one door, and it's just this small office room, and there's an ICP machine in the corner, right? And I look at it, I said, that's an ICP machine. And so hang on, this is great then, because we can run our exploration samples here, and we can do a full suite of 30 or 40 elements or something, and it'd be great. And he looks at me and says, I don't use this instrument for rock samples. I was like, well, what's it doing here then? Was it broken, or are you missing some spare parts, or why is it here? Or you don't have an operator maybe? And he says, yeah, we have the operator. We know what we're doing. The machine's fully operational. Every Friday, we take a urine sample from all of the workers, right? And we run the urine samples through the ICP machine and for mercury analyses.
Why?
So he says, and I'm just like, look at him and I'm going, okay, yeah, I think I know where this is going. And he said, yeah, anyone who has mercury in their urine is handling mercury. It's gone into their bloodstream. So it means they're stealing gold.
Oh,
So they're
because you
out.
had visible gold
Yeah.
oh my God.
Yeah. So it was, yeah, with a really high grade, lots of visible gold in some of these ore shoots. And people would get their own samples, stuff their pockets, go to the toilet and grind them down with basically a metal pestle and mortar, mix it with mercury and beneficiate the gold basically there and then and take it home with
What?
them. Yeah. Unreal.
Maybe
Okay,
they were still
back to
making
the
more money
commercial
doing that and getting fired by the time they were caught. Oh my
Yeah.
God. Oh, that's wild.
I know. So yeah, $500,000 machine that's how much it mattered. That would obviously would have paid for itself over a certain amount of time
Yeah.
in reducing gold theft, right? Yeah, not for exploration samples.
Oh my God, that's wild. Gonna take a minute to get over that one. I don't know that I have follow-up questions. That is, I've never heard something like that before.
That could be an exploration technique in itself, right?
Yeah.
Test the local community.
Oh my God. Okay.
That was not in my audit report, by the way.
Now everybody's finding out about it 15 years later.
Yeah. I'm not sure what the QC was for that.
Oh my God. So what did you
Yeah.
spend the $500,000 on? And what is it doing? Oh, okay.
Yeah, yeah.
Okay. Interesting.
Anti-theft.
Anti-theft. Yeah. Okay. Wow.
But yeah, it's kind of wild out there. And with all this Fiji, it's just too tempting.
Yeah, reading about it, it sounds like a wild deposit. Yeah.
Yeah.
Were they just seeing it during like blasting? Because if you're in the core shack as a geologist, you're going to be handling it. You're not benefit. Oh my God, I can't even speak today, but you're not.
No.
Yeah.
But yeah, the thing is, in the core shed, you've got the core cutters and you've got samplers and people handling things. We did get to a point with the exploration where we had a drop safe, or the exploration manager had a drop safe in his office and would put pieces of core in there that were especially high grade or very spectacular and wouldn't get cut. And of course, that totally freaked me out from a procedures and chain of custody standpoint.
Right.
Because there's core missing. It's okay. It's in the manager's safe. And you're like, no.
Next
Anyway,
level. Okay.
needs
Okay.
must. Yeah.
Yeah. No further questions, sir.
Rest of the case.
Yeah. All right. So let's move on to the topic at hand. Let's talk about low sulfidation epithermal. I'm in the mood now. I can't wait. So I've separated this into some general questions on low sulfidation that I think are a combination of questions that maybe I've always had, and then hopefully other people have had too. And then also some really specific questions on such a spectacular deposit as Porgera. So I'm looking forward to that one as well. All geochemistry related. If we go a little bit off topic into some kind of structure, that's fine. No geophysics allowed though. So as always. All right. So to start off, just get us all on the same baseline. What are some of the key geochemical and physical characteristics that differentiate low sulfidation from other types of epithermal systems?
Yes, you mentioned structural there, and so I might actually just first start with the physical side of things.
Sure.
And another thing that not many people might know about me is that my master's dissertation was on the structural controls on mineralization at the Guanajuato mining district in Mexico, which is a low sulfidation epithermal gold district.
I thought you were going to talk about structural coal or something in Wales.
No.
But that's cool. Okay. We're
Yeah.
getting right into it.
Yeah, so actually, yeah, I studied the structural aspects of the deposits back then. That was quite a long time ago. It's the classic, I guess, from the early 80s, the classic Buchanan model, where you have essentially this sort of Y-shaped set of veins, a main fault with essentially, a splay going off at an acute-ish angle, heading towards the surface. And these systems, I think in the models, you might see indicative depths of several hundreds of meters, so 400, 500, 600 meters maybe. But I think a lot of systems are actually shallower as well. The entire system breaks to the surface or the paleo surface, just like the high sulfidation deposits that we talked about in a previous podcast. But the low sulfidation deposits, if you think about this sort of Y-shaped fault system, which is then replaced or infilled with vein material, so essentially veins, where they meet at the sort of crux of the Y is usually where the bonanza or the highest grades are, and the space, I guess the structural kind of low pressure zones in there generate these breccia, can be quite large breccia bodies, which are then mineralized, and so that's where the high grade mineralization usually is. But like I said, these things then come all the way to the surface. And yeah, from a geochemical point of view, then you have interaction with meteoric water. The waters from the surface kind of get drawn down into the system and circulated, and those waters are what provide basically the fluids for the mineralization itself. So the main difference between high sulfidation and low sulfidation deposits is the meteoric water is really what the fluid source is for the low sulfidation deposits, whereas the magmatic fluids and magmatic waters are the source of fluids for the high sulfidation deposits. And so really, when we talk about high sulfidation and low sulfidation, quite simply, it's not necessarily the amount of sulfide minerals in the system. It relates back to what's called the sulfur fugacity. If a system releases sulfur and basically deposits sulfur very, very readily, very quickly, you'll be in the high sulfidation deposit, and that's why you get a lot of the sulfur minerals like sulfur salts and tennantite tetrahedrite, adularia, so sulfates. Whereas in the low sulfidation deposits, the sulfur is a low fugacity, so it's not released into the system, or precipitated into the system as quickly. So you get more iron rich. So you have pyrrhotite to pyrite, and you won't get these other sulfur minerals. So you might get a similar amount of sulfides, but you don't tend to get a lot of sulfates or sulfur salts. So that's basically the low sulfidation systems. They're nearer to paleo surface is where they're formed, and they have the meteoric water, and they have pyrite pyrrhotite as opposed to the higher sulfidation assemblage.
I think that's a pretty good summary. No notes. I think then moving into our next question, which is tying in with this one, what kind of pathfinder elements would we see commonly associated with low sulfidation epithermal? And do they have an evolution in their signatures with depth or distance
Yeah,
from the vein, rather?
Yeah, distance from the vein, depth. So again, if you've got an intact system, you'll tend to see high mercury. So mercury is a really good pathfinder for being near or on top of a low sulfidation deposit. And then not just the usual suspects, really. As you move down vertically in the system, you have antimony and arsenic associated with the gold. You'll still have gold. You might not. The mercury part of the system usually doesn't really have much gold at all. Okay, but once you start getting into the antimony and arsenic levels, then you should start seeing some gold anomalies or some reasonable, maybe not all grade gold, but certainly, yeah, some gold anomalies. And then, like I said before, as you get down into that sort of bonanza zone, then the sky's the limit, really. You can have some really high grade gold and silver grades. There's a lot of low sulfidation silver deposits as well, especially in Mexico, for example. Those are the normal pathfinders you usually see. I think probably mercury is a bit more prevalent pathfinder in low sulfidation systems than maybe a lot of other gold systems.
Is there a way that we can use vein textures? Because some of the vein textures in low sulfidation are quite spectacular with their crustiform, coliform, and then also the breccias as well. Can we use that to help us with our interpretation or in our exploration strategy?
Yeah, absolutely. This is really important when you're out mapping to get a handle on and map the distribution of the various vein textures. So yeah, you've got coliform, crustiform veins that are very close to the surface. And then again, as you go down in the system, we get quartz, okay, and if you like, more banded, not crustiform or coliform, but just more sort of typical veins where with banded, okay. Basically, when you're in the upper zones, you can estimate basically how far how far above the system you are. So you can say, okay, if I'm in the coliform or crustiform banded veins, then yeah, there's a couple hundred meters I have to drill through to hit the target. Right? You want to be mapping the main faults and the structural sort of framework, so you've got a feel for what the principal structure is, the principal fault is, and that's the one that you're going to target in your drilling, and then try and hit it 200-300 meters below where you see coliform or crustiform veins. Some of these vein arrays, if you like, they're like stockworks, and in some cases, a little bit further down, you might see these bladed veins where the calcite has basically been replaced with quartz, but it's all this sort of bladed texture. It's quite spectacular. But if you map those out on the surface, and of course, if the surface has some relief to it, so you're mapping out, let's say, some vertical variations as well as you map around the project, you'll get a feel for how the system is evolving and how far above the potential bonanza zone you are.
So we've talked about some elemental variations, we've talked about the veins, but I think something that naturally then, to me at least, as a next step lens is, have you at all worked with hyperspectral data to look at these alteration halos? A lot of, not all, but many of the minerals that are described in low sulfidation deposits are spectrally active. So can we use this data and geochemical data together to look at the alteration halos in these types of systems?
Yeah, again, I would say I've definitely used the handheld spectrometers alongside geochem sampling in at least a few of these systems. And I guess typically what you think of kaolinite or kaolinite smectite, I suppose, being far away from the deposit, or let's say in that sort of surface zone or near the surface zone. And as you get deeper, it'll grade into sericite. And in and around the sort of the main bonanza zones and where most of the mineralization is, you'll see a strong association with adularia. I've used, like I say, but it's not, that's what you typically think of, but you've got to try things out, right? So it's like we talk about quite often the exploratory data analysis. So as long as you've got data, you can do your exploratory data analysis. So for example, combining the geochem with the spectral data, there was one deposit I was working at, and we had some surface sampling and some drilling, and then we wanted to extend this soil grid. And essentially, by looking at the spectral and the geochem data from the drill holes along this one line, we found that, in fact, the high crystallinity kaolinite was associated with the mineralization in the veins. Okay, you probably won't see that in the model or anything, but in this particular district, that turned out to be the exploration tool. So it's okay. Now all we've got to do in our soil samples across the ridge, across the region, or across the district. Oh, and the other thing actually from the geochem point of view was that the antimony anomalies were very strong around the veins as well. So in the surface sampling, that's essentially what we ended up looking for. So using the exploratory data analysis, pulled out all the samples where we could read high crystallinity kaolinite, and then plotted the antimony in those samples. And lo and behold, the high antimony lined up along lineaments, and then it turned out that those were the exploration targets, or the extensions of the along strike extensions of these veins. And guys just basically went and put together a drill program to drill the antimony high spots along these lineaments. Each district, each deposit, I suppose, like all the other deposits, the deposit types, each individual deposit's different. It's got its own sort of special characteristics. But if you generally know what to look for and you have enough data, then you can figure out what specific keys to exploration are in a particular area. But absolutely, I'm a big advocate of collecting spectral data along with the geochem data for all the samples. And I think I probably mentioned it on one of the other podcasts. In South America, that was just part of the protocol for Barrick, is that every sample we took, whether it be drill sample or surface rock sample or soil sample, we would run it for 4-acid multi-element ICP suite, fire assay gold, and we would run it on a handheld spectrometer.
Thank you. That was really interesting. Pivoting a little bit, and you mentioned Barrick there for a hot second, but when you worked for gold companies, whether they were big companies or small companies, did you often target low sulfidation epithermal? Or was it something that if you noticed that it was a low sulfidation, you were not so interested and you would move on?
Yeah, generally speaking, Barrick was very, in my view anyway, very model driven when it came to exploration. And when I first started with Barrick, I wasn't like 100% comfortable with that. But what I realized was that a large company like that, who And it would be the same for other large gold producers. If you want to produce, let's say, in the region of 5 million ounces of gold a year, and you want to do that from, let's say, no more than 10 mines, that means each mine has to produce 500,000 ounces. And then you want mines with significant mine lives, 10, 20 years. So, of course, you're looking for deposits that are in the 10 plus million ounce range. And that's bigger than most of the vast majority of the low sulfidation epithermal deposits, or at least when they begin as, you're going to end up with having to have a bit like a district with several deposits in to come near that sort of endowment. Barrick being driven by model-driven exploration, they would only really look for the deposit styles that would commonly provide or deliver large deposits, very large deposits, and at good grades as well. For example, in Barrick, we used to look for orogenic deposits, we used to look for the high sulfidation deposits, we used to look for kaolin deposits, but there wasn't a specific sort of exploration effort, if you like, for low sulfidation. Yeah, so we focus on those other deposit types and porphyries, the larger deposit types. Now, notwithstanding that, we're going to talk about Porgera, which is a Barrick deposit, and they didn't sell it as soon as they acquired Placidome. There are these giant low sulfidation deposits, which are the exceptions. And I remember I was in one of the strategy meetings in Barrick, and the head of exploration turned around and said, I don't want to design a program to look for low sulfidation deposits when it's hard enough to find a mineral deposit in the first place, or an economic mineral deposit in the first place. And then we're looking for a subset of this deposit type. Only a few of these alkalic, low sulfidation systems would deliver Barrick-sized deposits. It wasn't on the list really as something to go out and look for.
That's really interesting. And I think it's such an interesting point to make.
The thing is, what I realized after, it's obvious you get into your track of, okay, this is the deposit size that we're looking for. After that, when I started working in consulting, I've worked for private companies, I've worked for all sizes of public companies, and a 1 or 2 million ounce low sulfidation deposit will really make a big difference to a smaller company and even mid-sized companies. So these deposits are significant. If you are in the mindset where 1 or 2 million ounce deposit is exactly what you're looking for, then I think this will be a very good deposit type to have on your list, because they are reasonably common as well. Like if you compare it with gold porphyries, or I don't know, someone's going to pull me up on the stats or something. But anyway, it's my feeling that, yeah, the low sulfidation deposits, they're out there. They're relatively small, and generally speaking, but they can be very economic because, of course, these bonanza type grades that we've been mentioning.
Yeah.
So they're good deposits to look for. It's not for everyone.
I like that. That's a really interesting way to put it. I think you brought up something really interesting in an indirect way too, because we talked about you working in-house and then as a consultant, and something that I don't know, maybe I've gotten a little bit philosophical as I've turned the page on 2025 here, but something that I've been thinking about a lot, because now I find myself personally pulled in a lot of different directions and maybe drawing upon your experience. And I think it would be something interesting for everybody to have access to your thoughts on this. But it's just that whether as geochemists we're working in-house or as consultants, and arguably even when you're working in-house, you are a consultant. What is our job as the geochemist, in the sense of, we know where we start generally because we're being pulled into something, but where do we stop? Where do we have to say, okay, this is outside of our purview, and move on? Where does additional expertise need to be called in? Or why does it happen sometimes that a company you'll see has a huge relatively team of geochemists, maybe 5 or 6 in a large company, and then all of a sudden you see them being pulled in all different directions into different positions? So I guess to pull that all back in, what is our job as the geochemist?
Yeah, that it does vary a lot, like you said. So when you're in any sort of technical specialist role in a big company, responsible for that technical speciality in multiple projects. You want to make sure there are some fundamental things happening in all of the exploration projects. For example, you have, let's say, a contract with one lab, and you're all analyzing the samples from all the projects, the same, similar suites of elements and similar analytical techniques. You've got the same QC, or you've got equivalent QC protocols in place across all the projects. So some fundamental things that you need to be doing in terms of collecting the data or acquiring the GeoChem data. And then when it comes to the interpretation and, well, strategizing, okay, what's designing sampling programs, what's more appropriate at a particular exploration stage, at a particular project in a particular terrain, whether it's stream sediment sampling, for example, or soils or rock chip grids and things like this. And then it comes to the interpretation. And I see a lot, there are basically two ways of thinking of it. There's never enough time, right, to do everything. Okay, so you can say, I'm going to spend time, my in-house geochemists are going to spend time on, let's say, making sure we're compliant with QC protocols and things like the National Instrument 43101 or the JORC requirements, for example, right? Or you could say, I can externalize that because we can basically bring in QC people and people to audit my projects and my procedures and so on. And my in-house people can focus then on the interpretation. Or you say, no, I'm going to outsource the GeoChem modeling because it's a very specialized area and it needs to be done, let's say, with people with lots of experience who've seen lots of deposits, and so they can really add a lot of value to the data on the other end. So it just depends on the overall sort of strategy of the company and how they use their internal technical specialists, and they externalize some of the work. In terms of where do you stop and where you end, the thing is with geochemists is that you start to, if you are looking at the data and doing the interpretations, you end up with a very holistic, a very good understanding of the project area, because you use the geochemistry to inform lithology. You use the geochemistry and, like you said earlier, the spectral data, if you're collecting it, to map out the alteration zones. And then, of course, you use the geochemistry for targeting the specific elements, either the pathfinder elements or the target elements that you're interested in. So the geochemist ends up having something to say in the geological discussion, have something to say about the alteration discussion, they have something to say about the anomalies and the high spots that the drill targets, essentially. So after a while, you have a geochemist who's very familiar with all of the projects that the company has in a certain region, okay? And they also have a very good understanding in detail of the systems that are being explored. So what then happens is somebody in management turns around and says, oh my gosh, look at this bright spark. They're across all these different targets that we've got. They have a pretty good understanding of the exploration stages and scales, and a pretty good understanding of what they're looking for, what we're looking for. And so this person is, performs very well, and then they'll take them out of the technical specialist group and have them maybe run a big project or one of the high priority projects in the region or in the company. So it's happened when I was at Rio Tinto, it happened when I was at Barrick. Technical groups of geochemists, they basically come and go. At one point you might have, like you say, you're in a big company, you might have half a dozen geochemists. And then a couple of years later, you might just have one or two. Not because they've left the company, but now because they're in other roles. And I was the geochemist for North America and Rio Tinto and Kennecott, and for 2 years, and then next minute they have me running the diamond lab in Thunder Bay. Okay, so doing something else. Then I was the chief geochemist with Barrick for 7 or 8 years, but eventually they sent me to South America to be the chief geologist there. And I saw lots of other other geochemists in Rio Tinto and in Barrick coming and going in and out of the role. I think we've mentioned this on another podcast. The geochemists I think it's almost like a natural career path that you end. If you're within a mid-size or large company, you're going to probably end up running a region or being an exploration manager at some scale at some point in your career.
Well, there you have it.
Yeah, I'm not sure if I answered all of the question,
I
but
think the question
I
was very
guess,
broad because,
yeah,
yeah.
where to stop. You do have to stop on a particular project because you've got to go to the next one and support all of the groups. Basically, you end up prioritizing and you say, I can support this project in this way, I can support this other project in another way. And to fill the gaps, you do bring in consultants. So even if you're in a company with half a dozen geochemists, there's still too many bases to cover. So there'll be probably some need to bring in some consulting people. And then, of course, when the overall geochemist group is down to one or two for the entire globe, then of course there's more reliance on consultants. And so it's just maintaining that network. You were saying earlier about being a consultant, you have to be in an industry for 30 plus years. We've got this network of people that I've worked with around the world, and they know me, I know them. If they call me, they know they've worked with me before, they know how I work, they know what they're going to get. And if I go and work with them, same thing. We've had other experiences in the past, and I know how they work and how they treat people and how they interact with the team in general, and you know what you're getting yourself into, sort of thing. But yeah, certainly there's if you can't do it yourself in-house, it either is not going to get done, so it just gets bumped to a lower priority, or it gets bumped to next year or the next budget session, or you bring someone in from outside to help you do it.
No, I think this is really helpful. And I think it was a really good question for us to have on the podcast, especially with somebody that's had, I can't quite tell at this point. We started at 20 years in industry. Then a few minutes later, we're at 25. Now we're at 30 plus years in industry. So we'll
Well,
see.
okay, 1991, whatever the
I'm not
2025
doing,
minus.
I'm not doing that math.
Yeah,
29 and
so it's
counting.
plenty.
All
Yeah,
right, let's
yeah.
switch to talk
No,
about
well, I mean,
Porgera.
yeah.
Because that paper, not that like the paper was super exciting, it was written in a typical fashion. Nobody's gonna be bored by it. I'm not like hating on it, but just the deposit itself, I was about to do a bit of a job on it with hyperspectral before I left a previous company. So I never got the chance to see beautiful core from it. And so now I'm reading this paper. You've worked there, which I don't know why I didn't think of before because it makes sense that you would have worked there. But yeah, I'm super stoked to talk about it. So, from someone that know, maybe just first tell us what Porgera is, tell us why it's special. Just give us like a little bit of a summary about the deposit.
Okay, yeah. Porgera is a low sulfidation epithermal gold deposit. It is alkalic related, so there's a subtype low sulfidation alkalic, and it's special because it's a huge deposit. So geologically, there's differences, but economically, it's enormous. I think in the paper it talks about 30 million ounce resource.
I saw that.
That's yeah, what's been mined and is what's still there in the ground. Of course, that varies. It depends on the cutoff grade that you use, all of that. But yeah, essentially, it's a massive deposit. Yeah, and yeah, it's typical insofar as you have a bonanza or very high grades in some zones, and it is zoned vertically in a similar way as we've been describing in other epithermal or other low sulfidation deposits. Yeah, so
Where's it
um,
located?
oh right, okay, so it's in the highlands of Papua New Guinea. Yeah,
Okay.
yeah.
So far away from us both right now. So it's fun. I don't think I've yet really chatted about something, definitely in PNG on the show. So new area for us. Was there a particular geochem strategy there, or was there something when you first got there that you were like, oh my goodness, we need to know this and we need to find this out in terms of the geochemistry?
Yeah, there was a concept or amongst the geological team there. As exploration geologists, we get a feel for what are the sort of more useful pathfinder elements in a certain area, especially if you're working at a mine and doing near mine exploration. You got a feel for what the particular favorite, if you like, or best or most useful pathfinder elements are in a certain area. But the real standout thing, and I suppose geochemically, about this deposit is that I hadn't had experience with before was the almost, I say, one-to-one sort of relationship between this mineral roscoelite in the selvages of the veins, of the gold veins, and the mineralization. Roscoelite is a vanadium sericite or a muscovite. And so the sericitic alteration that's really in close to the veins has vanadium in it. That version of sericite is called roscoelite. And when you go to Porgera and anyone in the geology department or metallurgy department, they'll immediately, everyone's very familiar with the fact that roscoelite is an important indicator that you're on some productive veins, on some veins that will be carrying some good gold grade. And like I say, I hadn't had experience, I hadn't really seen roscoelite anywhere else in my travels and experiences. I'm not working, for example, not in the low sulfidation systems that I worked in Mexico, so I hadn't come across that before. And I think the roscoelite, sorry, the vanadium probably is an indication of probably some magmatic relationship. So I know earlier I said basically the main difference between high sulfidation and low sulfidation is that fluids are magmatic in high sulfidation and meteoric in low sulfidation deposits, but the Porgera deposit is associated with an alkalic intrusive at depth, and there's talk about the system being telescoped, which basically means squashed together, like concertina sort of thing together, where you have very deep looking features, whether it be textures or fluid inclusions or something, that aren't all that far away from quite shallow features, like vein textures, near surface vein textures, and geochem. So basically, in the Porgera system, there probably was a combination of meteoric and magmatic fluids at play at certain times during the formation.
Yeah, I had seen mention of things like A and B veins, and I was wondering if they weren't talking about similar kind of classic Gustafsson and Hunt kind of stuff from like porphyry work. And I was like, okay, we have some A veins. Weird. Um,
There was an earlier event as well. It's described as being an earlier event as basically base metal pulse or base metal stage of
mm.
mineralization, which was not carrying any precious metals. Maybe that's more of a higher, I don't know. I think there might be more of a higher sulfidation event. And then, yeah, basically, yeah, the stage two was more of a low sulfidation.
And the other thing I just
Yeah,
wanted
more
to
of
add
a
is I don't think that anybody's ever given such a great description of telescoping before. It just gets squished.
it's
Most
not
people just make
particularly
it really
scientific.
complicated.
Yeah.
That's for a different day, though. We'll talk about that when we talk about porphyry geochem exploration, like maybe next year, because that's a big one there. But so we'll leave it for now. But I just really enjoyed that definition. So Porgera paper said that it was structurally complex. So that's what I'm going off of here. When you were, and maybe this can be just more of a general question as well, but when you're planning sampling grids or interpreting trends, like how are you trying to integrate the structure into that? Especially now we know you're a structural geologist yourself.
Yeah. The thing is at Porgera was if you're not close to the Romani fault, all bets are off kind of thing, right? You asked earlier about strategies as well, sampling strategies and things. Yeah, it as long as you're near the fault, you could be doing exploration. You could be running your sample programs over, let's say, the surface expression or the extension or the along strike traces of the Romani fault. So this is a fault that runs almost east-west, and on a regional basis, if you think about the arc, it's still all happening. Papua New Guinea is a very seismically active place, and so there's still subduction going on offshore. And let's very generally speaking, let's say the subduction is happening in a sort of northeast direction. Okay, so the mountain range essentially is northwest, southeast trending. Okay, and there's a transform fault, okay, that runs northeast, southwest, which so on the regional basis, you've got folding, okay, associated with all of this subduction, which is verging towards the northeast, and then you've got this huge transform fault, which is northeast, southwest trending. Locally, you have this almost east-west Romany fault at Porgera, which controls all the mineralization. Okay, so as you go in, this kind of speaks a little bit to the various scales of exploration. Porgera is at this very interesting sort of intersection, these two very regional features, okay, crustal features. But when you get into the local scale and the deposit scale, the most important structure has a completely different orientation. Anyhow, I think the Romany fault tips south. I can't remember exactly, because the ore bodies are essentially close to that fault and subparallel to it as well in 3D. So they plunge reasonably steeply towards the south, I think it is as well, right? So from an exploration point of view, there's no point in going off away from the fault and running soil surveys and things, because unless you think you're going to find a whole different beast in the same district, then you're barking up the wrong tree. So yeah, structure was very important in terms of just staying close to the main, or maybe splays off it. As we were talking about in cross-section view, the classical sort of low sulfidation model is this kind of Y-shaped fault vein system. There were splays in 3 dimensions, splays that would potentially coming off the Romany fault at depth and coming up towards surface that I think we ran a few exploration projects along those, but honestly, it's like about 10 or 15 years ago. I can't remember now exactly which ones became more successful. But clearly, there's been a lot of ongoing exploration success there because it's still in production and there's still more resources in the ground to mine. So yeah, it's just one of those districts that kind of keeps on giving.
Was there any time where the geochemical data led the geology, helping to reframe the model or identify something new that wasn't obvious from just core logging alone?
In Barrett, there were different teams doing the mine exploration and what we call the global exploration. So in Porgera, as the global exploration team, we went in and ran the mine exploration for a couple of years, 2 or maybe 3 years. And then after that, it was handed back to the mine, and the mine were doing their own brownfields exploration. So there wasn't an awful lot of continuity because you're there, you have a team in place, you put a team in place and they do the exploration for 2 or 3 years, and then they switched out. And to be honest, the follow up and to loop back and say, oh, look at the impact we had 5 years ago. Reading this paper was really interesting because it's all condensed into one paper, right? So this was a very good paper for me to read because it was written 2020, so that's 7 or 8 years or something after I was working there, and it was nice to see it all laid out in one place, almost for the first time for me. Yeah, so yeah, we ran, like I said, the GeoChem programs. We started collecting the multi-element data. We started using the commercial lab, and I guess I'd moved on, right, by the time all of that data all of those data were in a sort of fit state to be modeled up.
Maybe this is talking a bit more general, or we can focus on the stage 1 and stage 2 mineralization described at Porgera. But something that we see here, and obviously I would argue was a lot of studies done to have separated out the different stages of mineralization. But would there have been an approach that you could have used if you just had the 4-acid data where you're looking to see, number one, do the different stages matter? And if you believe that to be true, pulling apart those different stages by just having a general 4-asset data set? Would there be specific element ratios, thresholds, or vectors that could work?
Yeah, the main difference really is that the early veins were, well, carbonate veins and with lead zinc and really no precious metals. And the main stage veins were these gold, silver veins with roscoelite along in the selvages. So it was quite simple, really, I suppose. It's
No
not
big
like there
deal.
were. It wasn't no big deal, but it's not like you've got half a dozen cross-conventional brecciated breccias and all this kind of really complex stuff going on. It's just, is there a roscoelite selvage or not? And from the geochemical perspective, yeah, what we would want to do, what we would have wanted to do was to basically map those the sediments and the volcanics and if we had any intrusive there in any of the drill holes. So we could have made a lithogeochem model with the drill data. But again, if you're not close to the Romany fault and if you don't have roscoelite on the vein salvages, then it's quite macroscopic in that way. Just the logging is very helpful.
Interesting.
The other systems I've worked on, and especially as the last whatever it is years as a consultant, I have worked on other low sulfidation deposits, like not alkalic related ones. Okay, so the smaller type, and the geochem helps a lot there because a lot of times either people don't recognize adularia because it's just another whitish mineral, or because they don't want to make that call. They're not confident in making the call, or maybe it's too fine grained and they just don't notice it in the surface environment. But I have done geochem modeling on some low sulfidation exploration projects where just looking at the potassium aluminium versus sodium aluminium ratios, so the element ratios, mole element ratios, basically postulated or interpreted, right, that there's adularia in these samples or in some of these samples, and actually where you're getting your gold anomalism seems to be controlled by the adularia in the samples. And then I've had the project geologist look at me and said, no, there's no adularia here, but this is in surface mapping and sampling, right? Then they've gone ahead and drilled a hole and then hit adularia at depth that they can recognize because it's coarser grained and it's fresh because it's in the drill core, and gold mineralization. Okay, from a geochem point of view, if you're far away from the deposit, whether it be vertically or horizontally, you can definitely start interpreting the presence of some of these alteration minerals. It's not something that we specifically did at Porgera or that was done there, except for the vanadium and the roscoelite. Elsewhere, it'd be very useful because you can pick up on these minerals or the potential presence of these minerals that aren't necessarily recognized straight away.
Yeah, maybe something just like thinking really quickly, if you knew that, arguably, let's just say it wasn't as simple to define everything at Porgera using that typical potassium over aluminum versus sodium over aluminum diagram. You knew that roscoelite was important, but it wasn't obvious. Maybe you could just plot vanadium in terms of being that the color scale or the size or something. Could be a thought.
Yeah.
So let's just wrap this up now. We're not hating on the paper that we read, which was called The Geology of the Porgera Deposit in PNG by Hay et al. 2020. But just how did your geochemical understanding of Porgera jive with the paper we just read? Was it wildly different or was it pretty similar?
No, it's pretty simple, pretty similar to my recollections. But like I said before, it was nice to see everything like in one paper written down in a very logical way. But yeah, I can remember, like I said, the standout feature there is the high grades, the spectacular visible gold, the only basically two stages of veining and very different. So the lead zinc calcite veins and the roscoelite salvaged quartz gold veins. So yeah, it reminded me of when I was out there, the deposit. and the exploration in the region. So yeah, I enjoyed reading the paper. It was a good call.
Good call that you made. I want to thank you for being here. And I hope that you enjoyed talking about low sulfidation with us. I had a particularly great time, but it's also 2 p.m. in the afternoon and it's bedtime for you at this point. So I want to thank you for being here, Simon. I want to thank everybody for listening to GeoChemISTea. And yeah, just the tea was good this time. I found that incredibly different and wild, quite frankly. $500,000 to test for mercury in urine, but there's that. And yeah, if we're talking about geochem exploration and low sulfidation, I want to thank our sponsor, LKI Consulting, and to It's Water and Coma Media for our music. And I'm looking forward to chatting with everybody next month.